Ahoy hoy, I'm Planarwalk, and a small while ago I criticised Bill Gaede's series on science, and he responded. Now, I don't think it's the worst response that I've had, although it gets pretty bad at times, but it's definitely the longest. But despite it being the longest, he has still not answered the most important question. And Bill, you're probably watching it, so please, just say your name. Is it Bill Gaede or Bill Gaede, or are we all getting it wrong here? But all that being said, it was a pretty enjoyable response to watch, the second most enjoyable response to me that I've seen. I should probably actually get round to responding to the person who responded to me, who was actually an enjoyable person to watch respond to me, though there was some really bad audio problems. But anyway, the reason why Bill's response was so enjoyable to watch was because he wasn't trying to go for any cheap gotchas like I've seen other people do. He also took the response really well. It wasn't something where he got upset at me, it wasn't something where he tried to prove that he was better than me, and he didn't block me like Ken Wheeler did, so I respect that. That being said, I am going to poke fun at Bill Gaede because there were some funny moments. I don't know why, but this moment here is funny to me.
Okay, okay.
Alright, enough joking around. Let's see what Bill actually has to say.
Fellow made a video of my science series, and he addressed each one of the videos, each one of the points, and I commend him for that. He went in there and analyzed each point from his point of view, obviously, right? And I think more people should be doing that, not necessarily with me, but with their teachers. I mean, if you have instructors or teachers in college or school or high school or whatever, I think you should put them on the spot, see how much they know, if they can defend their positions. Okay, and that's, I think, good for morale in science. You need that.
Now, I agree with him to an extent here. The first thing is you must be willing to listen and to try and understand what you are told. And the second thing is don't just assume that you're more intelligent than them. You might be, but don't assume that. And the third thing is don't be really obtuse about things. Don't say, well, how do you know that water is affected by gravity? I think we can all agree that that is not the sort of question that you should be asking a physics teacher.
Okay, anyways, he addressed almost every point. I think he addressed them all, in fact. And one of the issues there is that, he said that he's not a scientist or that he's not a physicist, okay? And we don't hold that against him here. I mean, under no circumstance. We don't care if he's got a PhD or he's just got a high school. We don't care, okay? We're going to look at his arguments, okay? That's important here, at least. And so we don't care if he's got a Nobel Prize or he just came out of school.
That is actually good because both myself and Bill are regular people who do not have PhDs. But that being said, if you're disagreeing with people that have PhDs, you might want to ask yourself the question of why. Because you may have some valid criticisms, but having a PhD means that you understand the thing that you have a PhD in, or at least understand a decent portion of the thing that you have a PhD in. Now obviously it doesn't mean that you're right about everything, but if two people disagree, I'd sooner listen to the person that has a PhD in the subject than the person that doesn't. Hence why I take AB Science much more seriously than Ken Wheeler.
The other one is that, since he addressed each one of the issues that I raised in my videos, there's no way I can have one lecture with all that to address each one of those points. So I'm going to be doing that over the next few weeks. I was going to be addressing those same topics in one way or another in the next few weeks anyways, because that's why I was making the science series, okay? So in a way, it comes in very handy to use his video as a guide.
I'm glad I could help, but I will say that you did get some things really badly wrong. It pained me to listen to some of the things that you had to say. But another thing that he mentioned is that he's going to be responding to my videos for a few weeks. I don't know if he's finished or whether he still has a few more streams where he's going to be talking about my video or not. But the problem that we do run into with that kind of thing is we end up with the Aaron Ra versus Kent Hovind debate problem, where Aaron Ra made some points, Kent Hovind made like 5 videos on those points. Now, because Bill made some points that I feel like come from a place of deep misunderstanding, I do want to respond to them. But I also don't want to run into the Aaron Ra and Kent Hovind problem. And I think the easiest way to avoid this problem is to have a discussion. That way we can respond to each other in real time rather than having a video back and forth. But if you're keen for that, you can reach out via email, Twitter, or Discord. Preferably Discord because I use that more. It also has voice and video chat in it, which makes it really ideal.
You ask a kid, how did the cart move from A to B? Okay? And he says, very simple, I attached the cart to a horse, and the horse pulled it, and that's how it went from A to B. And we all look at that, if he shows us a movie of that, right, or even with his explanation, and we all understand it. We understand it, why? Because we see all the objects. Okay, we see everything there in front of us. We see the cart, we see the reins, we see the horse, and we see it moving. We see the movie of that, and we all understand it just by looking. You don't need to go to the university. You do not need to understand mathematics. All you need to understand is how that cart moved from A to B, and a 10-year-old can tell you that.
The problem, though, is that it can get way more complicated than just simply attaching a horse to a cart. Now you might ask, how can that be? Well, if you attach any random horse to the cart, will it pull the cart? Not necessarily. You need to make sure the horse is fed after all. You also need to make sure that the cart is not too heavy. That's why some carts have 2 horses pulling it. If you were to use a foal, then the cart is probably going to be too heavy. There is also the question of, is the horse trained? I don't know whether horses need to be trained, but if they do, then you're going to need a trained horse because otherwise it won't be able to move the cart to where it needs to go. And those are just some of the factors that could affect it. Note that the whole weight of the cart thing is probably something that you're going to need to use maths for.
If you're going to be doing gravity, if you're going to be doing light, if you're going to be doing electricity, magnetism, without a mediator, you're using black magic. And that's what mathematical physics has. That's why we call it mathemagical physics. They do it with black magic.
So Bill, I'm going to introduce you to 3 words that it's perfectly okay to say. Technically 4 words, because the first word could be one of 2 words. But these words are, we don't know. And you can also add yet on the end if you really want to spice things up. You can also change the first word for I and say, I don't know. My point is, if you've got 2 magnets like these that are exerting a force on each other, it's perfectly fine to say, I don't know what the physical thing is that causes that force to occur. The best that we can really do is say that there is a field there. What causes that field? We don't know exactly. It might be strings, like in string theory. It might be ropes, like in silly string theory. Or it could just be that there is a thing like space-time there that causes magnetism. Although, I'm sorry, Bill, but I highly doubt that your silly string theory is correct.
Okay, so here we have a rundown of what mathematical method is, which is the one that I'm going to be addressing, attacking, okay, analyzing. Okay, and essentially, the big problem is that this is not a scientific method. What this is just a method of research and persuasion and to give people something to do, to study as they call it. And studying is not science. Science is explaining us, telling me something that came out of all that work.
Okay, so Bill, that really doesn't look like the scientific method to me. It really does look more like your interpretation of the scientific method, especially seeing as invent technology is not part of the scientific method, and it's not confirming a theory either. So you got the first part of the scientific method correct, making an observation or asking a question. Very simple, we all know what that is. And the second part is to do a bit of research, because you need to know what you're talking about if you're going to try and explain something, obviously. And then the third part is you create a hypothesis which is a potential explanation for your observation. The hypothesis should be able to make predictions, so the predict part is actually part of the hypothesis stage. Then you do an experiment. This experiment will test your hypothesis. And then with the data that you get from that experiment, you have to analyze it. And then once you've analyzed your data, there are a few things that could happen. Your data could indicate that there was a problem with the experiment, in which case you might have to either do a new experiment or redo the experiment in a different way. It could also indicate that your hypothesis is correct, or it could indicate that it is incorrect. Now, if your hypothesis is incorrect, then it will inform other people when they try to come up with a new hypothesis for the same observational question. But before it can do that, there is another step: peer review. You need to get other people to analyze your data, analyze your results, analyze your findings, to make sure that there's nothing wrong with it. And ideally it would be nice if they could perform the experiment as well, although I'm not sure that that is something that always happens. And once you've done all that, you then get to publish the results, and it gets added to the large body of research that is out there. But that is not the end, because your hypothesis will constantly be tested. And you may end up finding that whilst your hypothesis is a good explanation for certain things, that there are certain flaws in your hypothesis that then goes on to spawn other research. But that is a pretty simplified version of the scientific method. It can get more complicated depending on what you're doing.
They invent technology, and they think that technology is proof of theories. You'll hear a lot of people out there just parrot and say it over and over again because they never even thought what they're saying about what they're saying. And they say GPS proves that general relativity is correct, and computers prove that quantum mechanics is correct. Because you wouldn't have a computer, it wouldn't work if it weren't for quantum mechanics and blah, 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 blah. And again, it shows the irrationality of all these people. Okay? Does GPS prove that time is a physical object? That you can warp, that you can bend like a banana? Does a computer prove that a particle can be at two places at once? Because those are the explanations they give you. And you say, well, if that weren't true, the computer wouldn't work. The computer works because of trial and error. That's how technology is made. Or like Mr. Thomas Edison said, I haven't failed. I just found 10,000 ways that don't work.
So there are a few things to mention here. The first is that transistors did not come about via trial and error. Transistors are a result of people studying the properties of semiconductors. Now, quantum mechanics and semiconductors go hand in hand. If you want to know about semiconductors, you have to know about quantum mechanics. Once enough was known about the properties of semiconductors, it was then realized that we could make transistors out of these things. And it's important to note, and I will keep reiterating this all the time, that quantum mechanics is entirely based on observation. Quantum mechanics is essentially a bunch of observations about the world that is really difficult to figure out why we are getting these observations. Now, as for the GPS, it has to account for relativity. If it's not accounting for relativity, it doesn't work. If relativity were false, then it would not have to account for relativity. And remember that Einstein came up with relativity before GPS was even a thing. So it's not like we got relativity from GPS. We had relativity, and GPS needed to account for that in order to work.
Someone, they vote for it, and they say, well, if you got 50% plus 1, then it becomes truth. Becomes a theory, okay? And from theory it goes to proof, and truth and fact. That's the way they work in mathematics. Yeah,
science doesn't work by people voting on it. It's not politics. You can disagree with scientific findings, but if you want to say that a particular set of scientific findings are false, you have to produce your own scientific findings that counter those scientific findings.
And they finally win an award and medals and so on, so that they have authority. You win a Nobel, then you can trash anyone on earth because, who are you? I've got a Nobel, what do you have? It's that kind of thing.
So firstly, it's the Nobel Prize, not the Nobel Prize. We are not giving these things to flat earthers who say the earth is not a ball. And secondly, not everyone who does science wins a medal or a prize. Most people just publish their work in a scientific journal and then do more science. If you're looking for prizes, then science isn't the thing you should be doing. You should be going to bingo night.
So here you see the what we proposing exchange. We're saying this is the rational scientific method. This is what science really is. It's rational explanations.
Okay, something that I do not see on there is a way to verify that your explanation is actually correct. Having an explanation is one thing, but actually verifying to make sure that that explanation is correct, that's the important thing. An explanation is not useful at all if it is incorrect.
And what is a hypothesis? Nothing to do with a theory, nothing to do with an explanation. Hypotheses are the objects, the definitions, and the initial scene with which you start your theory. You have to start the movie of your theory, your explanation somewhere.
There is no scientist in the world who would use that definition of hypothesis. A hypothesis is essentially stating, this is what I think is happening, and because of this, this is what I expect to happen in the experiment.
Okay, so what does this fellow say? Well, he made a couple statements from the start in his video, and it just blew me away. I'm saying, my God, how can we, be so different, And this is what he said, okay? This is how he starts his presentation. Give me a second here, and I'll get it started. All right? Pay attention, please. Okay, here it goes. The issue and argument raised in this rejoinder is the mathematical method has done well over the last 400 years since the mathematics revolution.
The scientific method has worked pretty well so far since its inception. We've managed to find out quite a bit about the universe, especially over the last couple hundred years. Okay, Bill, I'm very disappointed in you because you had this circle opening for me, but at the end, it just faded to black. I was thinking that you'd do something cool like a yibbidi-bidi-bidi, that's all, folks! But that aside, what I said there is true. We have discovered a lot in the last 400 years. For example, we've made significant strides in figuring out the structure of an atom. To start out with, we just thought that it was simply a ball. Then the plum pudding model was conceived, which was a ball of positive charge with negatively charged electrons in it. Then Sir Ernest Rutherford, someone who probably didn't have an accent, came up with the nuclear model, a positively charged nucleus with electrons orbiting it. Then it was discovered that electrons actually occupy different energy states, and thus we have electron shells. It was also discovered that the nucleus is not just simply a positively charged ball. It is occupied by protons and neutrons. Then it was discovered that the electrons aren't actually orbiting the nucleus, but instead they're occupying an electron cloud. And we can go further by saying that protons and neutrons are made up of quarks and all that kind of stuff. But you get the idea. The atom being made up of protons, neutrons, and electrons wasn't known about 400 years ago. And it's because of these discoveries that we have nuclear energy today. Nuclear energy would not be possible unless we knew this kind of stuff.
Now, when I heard that, I didn't need to go any further because he already said a mouthful there. First thought that came to mind is, I'm from planet Earth. What planet are you from?
I'm clearly from Vulcan, but not the one that we thought was in this solar system.
Please take me to your leader. Now, maybe I'm in the wrong planet. I don't know. Could be that I'm in the wrong planet and I need to find out. Maybe I went to the land of the Klingons.
So I wanted to include that part simply because I like his sense of humor here. It's not every day that someone responds to me and I get a chuckle from one of their jokes.
I'm saying that we have made no progress in the last 2,500 years, since the days of the Greek at least, right?
Okay, if you think we've made no progress in the last 2,500 years, then Copernicus, Kepler, Galileo, we don't think that we're the center of the universe anymore. Unless you think that the universe is geocentric, in which case you've got a lot more explaining to do and you're going to need more than playing jump rope for that, then we have made progress in the last 2,500 years.
In the last 200 years, more like 150 years, last 150 years, we went backwards. We got worse. We have more and more irrational explanations for common phenomena.
Like I explained with the structure of the atom, we have had quite a few developments, especially over the last 150 years. Just because you think it's irrational doesn't mean that it's wrong.
And so this fellow says we made progress. I'm saying we haven't made progress. One of us is on the wrong planet. Okay, it could be me. Okay, well, that's what we're going to find out.
Okay, I have to mention this, but what he said right there earns some of my respect, because admitting that you could be wrong is respectable. Like I've said before in previous videos, I could be wrong about things. I don't think it's likely that I'm wrong, but I do have to be open to the possibility.
And here's all the irrationalities that are rampant in mathematical physics. Now this is a very small list. I could tell you, I could go on and on and on and on. I've got a list this long, okay? But this is a good place to start. I mean, this fellow says that we have rational explanations, I guess, he's thinking about, or that science is doing fine, especially in the last 200 years. And I'm saying, you know, right now we have something called dark matter out there, dark energy. And those are two irrationalities, complete irrational nonsense, poppycock.
So dark matter is essentially, we don't know what it is. There appears like there is more matter than what we can actually see. Since its inception, some of the dark matter has been found. This was cold hydrogen, but not all of it. My favourite idea for dark matter so far is slow neutrinos. The problem with them is that they are very hard to detect. And because of this, we cannot say that dark matter is definitely slow moving neutrinos. He also mentions dark energy, and again, we don't know what dark energy is. It's just a placeholder for the universe is expanding, what's the energy that's causing that. On his list there, he also has black holes, and we've taken photos of black holes. They exist. And then he's got the Big Bang. There is evidence for the Big Bang in the cosmic microwave background radiation, and the universe is still expanding, so the universe is still banging. And then he's got the particle at two places, and I'm assuming what he means by that is wave functions, where a particle can be anywhere in the wave function, and you don't know where it is until the wave function collapses. Now I might be wrong here, but I'm pretty sure that the Bose-Einstein condensate, which is a different state of matter, is only possible if wave functions are a thing. Because when you cool things down to a certain point, you got things like the Heisenberg uncertainty principle in quantum mechanics that kick into action and cause some funky things. That is as much as I'm going to explain it because it's not something that I fully understand. Maybe that can be in a future video if I take a lesson on quantum mechanics. He then mentions time dilation, which again is a thing that has been observed. There were clocks that were all set to the same time, and then they were moved at different speeds, and then the times were out of sync. This is something that you'd expect if relativity is true, especially with these very accurate clocks that they had. He then lists alternative realities, and that is just a hypothesis, not even a theory. There is no way in which we can falsify it at this moment, so it's not really taken seriously. It's more of something that will occasionally be humoured because it's fun to think about. Then he mentions tachyons, particles that come from the future, and this is something that, again, we have no evidence for. There may be scientists trying to find evidence for them, but we don't have any evidence for them, so we can't say that they actually exist. And lastly, he says string gravitons from the 4D, and I don't think that there's any evidence for gravitons. Now, they may have been floated as an idea, but just because something is floated as an idea doesn't mean that we have evidence for it. So not everything that is on that list is something that science says is true. Yes, scientists may be looking for evidence of some of these things, but that's not the same thing as saying that it is a thing.
And the dark matter is on the inside pulling the universe inwards, and we have the dark energy, you know, kind of like the anti-gravity pushing the space outwards, okay? And all the galaxies are really stuck to the surface of the balloon. So as the balloon grows, the theory is that all the galaxies fly apart, and that's why the universe is flying apart according to mathematical physics, right, before our very eyes. And the first question that an irrational individual asks is, what's the white stuff? That's what we want to understand. And that's an answer you won't find and they won't give you. And they say, look, hey, it's an unscientific question. You cannot ask, you know, what is the white stuff out there?
And that would be correct. And the reason being is because there's no way to answer what is the white stuff, because we don't know. Because science only deals with what we can know. If there's something that we cannot know, then science has nothing to do with it. That's why science doesn't deal with the question of, is there a God? Because we cannot know if there is a God.
And, you know, it's like asking, they say it's like asking, what's north of the North Pole? Well, you know, north of the North Pole, you have Polaris. There's a star there. And beyond that, you have galaxies and stars and asteroids and what have you.
So here is a very serious question for Bill. Very scientific question. It's not actually scientific, but we'll say it's scientific, right? What are aliens like? And what planet do they live on? Serious question. Now, there is a reason why I asked this question, because it's very similar to asking what's outside of the observable universe. The answer is, we don't know. And it's far better to say that we don't know rather than pretend like we have some kind of answer. Making up answers to pretend like you have answers to questions that haven't been answered is the business of pseudoscience and religion, not science.
And the question here is that white stuff gives contour to that balloon, which is space. The balloon is space, so they're treating space as a physical object, because again, an object is that which has shape, and what we're staring at is that which has shape. So whenever you have shape, you have to have something giving it contour. You have to answer what is the white stuff.
But Bill, the thing you don't seem to be understanding is when you don't know the answer to something, you cannot answer it. If I ask you what planet aliens live on, you don't know the answer to that, so you cannot give me a proper answer.
Black hole. I mean, how irrational can you get other than the black hole?
I mean, seeing as black holes have been observed, I'd say they're pretty rational because you can't get any more rational than reality, right?
There is no such thing as a black hole because a black hole is zero-dimensional, zero size, and has no matter in it, and mass is the quantity of matter, if I remember correctly from high school, long time ago, okay, so give me a second here. It's the quantity of matter, a measure of a quantity of matter, of course, and if it's got no matter, it's got no mass. And so let's see, zero-dimensional, no volume, no size, no mass, no matter. Looks like they're talking about nothing.
So firstly, black holes do have matter, and therefore they have mass. I don't think anyone disputes that. And secondly, I asked a physicist about black holes having zero volume, and their response was, volume is a bit tricky. The radial coordinate becomes time-like inside the black hole, so it doesn't have a volume in the usual sense. Is that confusing? Yeah, it's actually pretty confusing. But if I wanted to actually criticize it, I would go ahead and learn exactly what it is saying about that. Fortunately, he did expand on it, more or less saying that time and space swap in character, so space becomes like time and time becomes like space. And so it would be like asking, what is the volume of a second in my room? Although, to be fair, that would probably have an answer, although it would be in decibels, which is not what we're talking about.
And let me rub it in just while we're at it, okay? Here we have two fellows, Professor Cole Miller, University of Maryland, and Professor David Harrison from the University of Toronto. Black holes are the most exotic objects in the universe. A black hole is a region of space. The matter that forms a black hole is crushed out of existence. There is nothing there. Okay, I hope that struck a bell somewhere, okay? What does Harrison say? An object whose gravitational pressure is so intense that the matter of the object is crushed out of existence. Okay, so we have no matter, okay?
So I think what that is referring to is matter as we know it, because black holes essentially are the extremes of the universe. If you put matter under the pressure of a black hole, it just wouldn't exist in a state that we are familiar with. It's like when people say that it's the end of the world as we know it. It doesn't mean that it's actually the end of the world. It's just the end of the world as we know it.
Okay, how about Big Bang there we have? Next one down on the list. Here we have Big Bang, okay? And I showed this the other day, okay? Our universe, according to mathematics, space, time, and matter are all in there. So we have space, time, and matter inside that tilted glass. That's pouring beer out. Makes me thirsty, okay?
Okay, now that I have seen that, I'm not going to be able to unsee it now. Thanks, Bill.
And the question is, how did this start? How did the first bit of matter start? And the way they calculate, or the way they figure this theory out, is they said, look, we figured out in the 1930s, 1929, 1930s, that all galaxies are expanding, are flying away from each other. Okay, so the world is exploding. They say, ha, we got it, we understand this. What's happened is yesterday we're closer together, and even before yesterday they were even closer together. So if you run the movie backwards, what you have is all matter condensing into a little point. A singularity. And you say, well, where did the singularity come from? I mean, can you tell me that? And they say, well, no, that's unscientific to ask that question. We don't know.
And once again, it is perfectly fine to say we don't know, because sometimes there will be questions that you just simply do not know the answer to. Because at the end of the day, it is better to be truthful and say, yeah, I don't know, than to pretend like you do when you actually don't. What happened before the Big Bang? Nobody knows.
That's the movie of the Big Bang. You know, it starts at frame number 2. It doesn't go to frame number 1 where the singularity is created. They say we don't know what happened there. We can't explain it. It's unscientific because we have no way of proving, blah, 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 blah. And essentially what they're saying is we cannot explain the mechanism of how something comes into existence from nothing. That's essentially the problem.
So one of the annoying things is when people will say that the Big Bang is essentially something coming from nothing, which is not true. It's something expanding. That's all it is. What happened before the Big Bang? We don't know. Was it nothing? Maybe. Was it something? Maybe. We don't know. The start of the Big Bang can essentially be seen as a limit to our knowledge. We can't see past that point because it turns out that it's really difficult to work that out.
And that's when the religious folk, you know, they look at them and say, they smirk and they say, you just don't want to say that it's God who made all this stuff, right? That's all your problem. And yeah, this is the issue. In that sense, I got to side with the religious folk, the traditional religion, because they've got the right idea. You know, why did you stop at frame number 2 and say, well, we started at the singularity? Well, how convenient. I mean, why didn't you start at, before the singularity?
It's because we don't know. It could be true that a god or gods created the Big Bang, but we don't know that. If you say that a god is responsible for the Big Bang, then fine. Show your evidence. If you think that the Big Bang came from nothing, again, fine. But show your evidence. And if you want to say, I don't know, then that's also fine, as long as you're not denying evidence.
Someone asked the question in Quora, and PhD answered the question. And it's how this question was answered that's important, okay? And which answers the question of how the universe came to be, how matter came into be. Okay, and here it is. It says, is it true that in quantum mechanics, particles can appear and disappear seemingly from nowhere or without a cause? And a PhD, this is a PhD, okay, he answers, QM obeys physical law, not magic. Oh, okay, good, thank God. And says, yes, the way things behave at the quantum level is often weird and very non-intuitive. Ooh, bad way to start a presentation. He's going to say that it's counterintuitive. Okay, I guess we're heading into irrationality here.
So something being intuitive is not the same thing as being rational. To some people, putting more petrol in their car to make it go faster would be intuitive because petrol makes a car go, and putting more petrol in a car, well, that would just make it go faster, right? But obviously that's not true, because if you put a lot of petrol in your car, then it's going to go slower due to the added weight. But if you put too little petrol in your car, you're not going to be able to get very far either. As someone who has designed video games, human intuition is just the worst.
And yes, during high energy collisions, all sorts of particles can appear, disappear out of the vacuum that were not even there to begin with. Okay, sounds like magic. But again, all this goes according to well-established theory, quantum field theory, not magic. So that's just a statement. These people are doing magic and saying, no, ours is not magic. Magic was what the traditional religions did. We don't do magic.
Well, they aren't doing magic because these are things that happen and can be observed. My question for you, Bill, would be, if they're not observing what they say that they're observing, then what are they observing?
Okay, so here's an example, okay? It's famous space-time, okay? And you have two versions of space-time. You have the ridiculous 2D space-time and the ridiculous 3D space-time. And you can see that one is sitting on top of space-time. The other one is drawing space-time towards its center. In this case, the Earth, right? And the question is, these two cannot both be right.
They're not actually how this works. They're just representations of a thing meant to make it easier for it to be visualized. Bill is confusing a visualization with the thing itself. Here's a good example. This map here must be wrong because it says that Libya is some weird bluish color right there. We know that that's not true. It's actually yellow. So this map must be wrong. Obviously that argument is ridiculous because that map is not meant to be a perfect representation of the world. But it is a very helpful tool if you want to know where one country is in relation to another country.
Space-time doesn't work down here. I can't explain using Einstein's equations, okay? I cannot explain why this pen drops to the table. I cannot explain it with I cannot apply Einstein's equation to here. You can only apply Einstein's equation with big masses out there in the global universe. You cannot say that space is so warped here that this falls at that rate. That's why it's falling.
Actually, yes you can. It's just that it's a little bit easier to use F equals G times M1 times M2 over R squared.
One guy says 3D spacetime. No, that's not what Einstein said. So this guy thinks he's very smart because he said, oh, I figured out how spacetime really works. No, spacetime works like the one on the left. For otherwise, Mercury's orbit, which is up there in the center, wouldn't work. You know, Mercury's orbit, the one Einstein applied his theory to, works like the 2D spacetime, the ridiculous 2D spacetime on the left, the two-dimensional one.
Except in Einstein's theory of relativity, spacetime is four-dimensional. So you've got that wrong, Bill.
This is what the theory says. The irrational theory of general relativity says. Here it is. Okay, this is the curved wall of time. They say time is a physical object like a wall. The Earth rolls around or slides along this curve, and that's why it doesn't fly out of the solar system. Very, very similar to the analogy of a roulette. You know, you have the little ball going around the roulette. Why doesn't it fly out of there? Because it's got this wall that's preventing the little ball from flying out. And this is no different. Okay, so it's the roulette mechanism.
Well, actually, no. The reason why the Earth doesn't fly out of the solar system is because it's attempting to travel in a straight line through space-time. And because space-time is curved, that results in the 3D path of the Earth also being curved. It's not a wall or anything, it's just space-time being curved and how objects interact with space-time.
When you show them this, you say, well, is this what you're saying? You're saying time is warped. Are you saying there's a canvas there that comes against the skin of the planet? You know, is our planet rolling or scraping around that depression? Is that why the Earth doesn't fly out? Because that's what they've explained. That's what they illustrated. That's what they told you, objectively. And then he said, Bill, you're not supposed to take the analogy literally.
And they would be right, because analogies are often used to help people understand something that they may not necessarily be experts in. For example, if I want to explain a computer to someone, I might explain it like an office. The amount of cores that a CPU has is like the amount of workers that you have. The speed of those cores is like the speed that the workers operate at. The amount of RAM that you have is the amount of disk space that you have to work with, and the amount of hard drive space is the space inside filing cabinets. Now you could say, well, okay, now I know that I shouldn't leave my computer on all the time because those workers, they have families. They've got wives and kids that they've got to go home to. And if you say something like that, you are taking the analogy way too literally. But as a quick aside, you never know, maybe their family is the slave labor that works in the graphics card.
If you're going to go in there and say, well, there's a depression and the Earth rolls around it and blah, 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 and then at the end of your class you say, oh, by the way, that was only an analogy. There is no depression. There is nothing coming up against the skin of the Earth. Then what have you said? What is your mechanism?
If you're actually taking a class, then you will get a full, in-depth explanation, rather than an explanation that is simplified so that more people can understand it. There is a reason why when I was taught about atoms at the age of 11, why I wasn't told about things like electron energy states.
Does the mechanism, that general relativity that Mr. Einstein proposed, is it rational? Can you use this to simulate what's out there? And they say yeah, it is, because see, we were able to explain, like, and this fellow mentioned that, he says that there's no planet called Vulcan that's close to the sun.
I'm glad that Bill said that there's no planet called Vulcan that's close to the sun rather than saying that there's no planet called Vulcan, because otherwise my joke from earlier just wouldn't work.
And what he doesn't understand, this fellow, and 99% of humanity out there, is that mathematics is tautology. What they do is they make an equation that describes what they're observing. So it better be a tautology if the equation is correct. It's just a tautology. It means that you're making a tailor-made equation so that it fits the observation. And that's what Einstein did with Mercury. He just went in there, put some variables in there, and he said, see, if we put it this, and this way, then we can explain the orbit.
So Einstein's theory of relativity does explain the orbit of Mercury without the need for an extra planet. But Einstein's theory of relativity isn't just equations to make the orbit of Mercury work. Like a lot of other things in physics, Einstein's theory of relativity has a lot of other consequences that occur from its equations. Those consequences being things like time dilation and gravitational waves, things that have actually been measured. And it also explains the results that we get in the Michelson-Morley experiment.
And what is Einstein's equation for Mercury is that it's a point mass. Okay, to use that terminology, it's a point mass. It describes the motion of a point mass around the sun. That's what Einstein's equation does. That's different than Newton's, which said, look, there's two objects, and they attract according to the inverse square of the distance. Okay.
So I'm pretty sure that a point mass is a simplification for when you don't need to consider things like the shape of an object or the mass distribution within that object. So if I'm right on that, and I could be wrong, then Newton's law of gravitation would also be dealing with point masses. Because r squared in Newton's law of gravitation refers to the distance between the center of one mass and the center of another mass.
Okay, so what's the problem with the canvas? Why is it irrational? Okay, why doesn't it explain? It explains Mercury, great, I'll concede. It explains Mercury rolling around the sun.
Oh cool, we've finally got Bill Gaede believing in irrational things like canvases, something that no scientist actually says is the way that the universe works.
Here we have the Earth and the Moon rolling around the sun. Okay, so we have the sun weighing down the canvas, okay, and then around that we have the Earth. It also weighs its little canvas, which is rolling around the other canvas, right? And the Moon has to roll around the canvas that the Earth created. Okay, so far so good. They're both the two canvases, the one for the sun and the Earth, in fact, even for the Moon, they all point downwards. Okay.
So this is an example of why you should actually properly understand something before you criticize it. This is the kind of thing that I would expect from a flat earther. Okay, that's not actually fair because, to be fair, a flat earther would actually be making more pigeon noises after knocking all the pieces over. But essentially what Bill is creating here is he's making a straw man based on his own misunderstanding. This is not something that general relativity says. If it were, then people much smarter than you or I would have already figured out that there's a big problem here.
Well, the problem with this is here, okay? Here you have the Earth on the upper right, and that's correct. They all are parallel with the ecliptic, essentially, right? In other words, the canvas there matches the canvas of the sun. But that doesn't happen with Uranus and its big moon Oberon. Okay, Oberon goes around the equator of Uranus, but Uranus is on its side. Okay, so Jupiter is on its side, and it has to be pushing the canvas towards the side. I chose one side, it could be towards the other side, but it doesn't matter. It would point east in this case, or it could point west. In order for Oberon to orbit the Uranus the way it does.
Bill, please just talk to a scientist. My brain cells are dying and I don't like it. If you actually knew what relativity said, then you would not be saying this kind of thing.
I want you to tell me objectively, okay, what caused the window to break. Okay, so here it is. So you have to tell me what caused the window to break.
So there's two questions that you asked here. The first is what objectively caused the window to break, and what caused the window to break. These are two different questions, although I don't think Bill realizes that.
Now, this is what we call objectivity. I should get every person on the planet who is more or less sane, right? and ask them, how did the window break? And the person should say, that window, that specific window. Person should say, a horseshoe went through the window, broke the window. What did this person answer? This is what he answered. Let me put this up here. He said, no one can objectively tell you what happened there, especially seeing as they're just cartoons. I couldn't believe his answer. So if I ask a 10-year-old, what are you seeing there, 10-year-old? What's happening there? And I think if I go to kindergarten, all the kids would say, well, Bugs Bunny jumped or dived, he dove into a rabbit hole. That's what they would say. That's what you're staring at. That's objectively what's there.
Okay, so it looks like I'm going to have to explain the difference between asking what objectively happened and what happened. When we talk about something being objective, we're talking about something that exists in the real world. Cartoons aren't real. If we talk about what objectively happened when it came to the cartoons that you showed us a cartoon. That's what objectively happened. Or at least that's what I think objectively happened. I might be wrong about that. Rene Descartes and everything. Now, if you ask about what happened in the cartoon, then yeah, people are going to say that the horseshoe went through the window, because that's what we understand happening in the cartoon, but that does not mean that that objectively happened.
Okay, so now someone comes to you, okay? Someone comes to you, he's a religious folk. He says, I've got a theory of gravity. Oh, okay, what's your theory of gravity? He says, here, I'm saying that angels mediate gravity. I say that angels carry astronauts to Earth. They angels that are here, they force the pen to fall, and so on. So I'm a little skeptical. I'd have to see it. Okay, I've illustrated it for you. Here it is. I'm going to show you. Okay, and so here he puts this up there for you, okay, so that you can verify what he's saying, the mechanism. And here you have the angel carrying the astronaut to Earth. He says that's how gravity works. And you might go in there and say, well, I don't believe in your theory. What experiments have you run? Wrong questions. Wrong questions. The person is giving you a mechanism. He's telling you a mechanism of how he thinks, what he proposes of how gravity works. We're not asking you to believe in his theory. We're not asking you what's the evidence, how many people have voted for your theory. We don't care about any of that. We want to understand what's in his mind as far as what he proposes for the mechanism of gravity.
Well, that's a bad way of going about it, because then anybody can tell you anything, and as long as they work a way to make it make sense, at least to you, then it's like, okay, well, I guess I've got nothing to challenge it with. Whereas my approach will be, okay, what is your evidence for that? If they've got no evidence, then why would you believe something like that? And if someone is telling me about something that they think is real, then I don't care whether they're asking me to believe it or not. I am going to challenge them on it and ask what the evidence is. Why are you telling me about this if you don't want me to believe in it?
And the question is, did you understand the mechanism that he's proposing? That's the question. And if you didn't understand it and you say, well, it's just a cartoon anyways. Well, then you got a problem. You got a mental problem. Yeah, you got a mental problem, because the question is, do you understand the mechanism that he's proposing?
Understanding the mechanism that is proposed by someone, and that mechanism being the reason why certain things happen, are two different things. One requires evidence, and the other requires you to just be able to understand what's being said. Alright, so I think this is where I should end this video because this video is getting close to 50 minutes long, and I was worrying about the time when it was getting to the 30-minute mark. Now, there is something that I noticed a couple of hours ago, and that is Bill is making a 4th stream responding to me. Keep in mind that I've only responded to one of his streams in this video. Now, if you're watching the premiere of this, then it should redirect to Bill's stream. That's if I can figure out how to make that work. Now, I will be in the live chat seeing what Bill has to say, but I want to be clear on something. Do not harass him. Okay? That's the one rule if you're going over there. My goal is to organise some kind of discussion so that I don't have to keep on pumping out 50-minute videos responding to his points. Because this video may be 50 minutes, but that's hours and hours of work that I've put into this video. Especially considering that I have had to cut out a large portion of what he has said, because otherwise this video would end up being about 3 hours long. What I'm also saying here is that if you have given support through Super Chats or through Patreon, that is very much appreciated, and thank you for doing so. Especially if your name is Hugh Jarsz, M.C.Nutkin, SHaKie, Wolfie, Maury, Greymorgos, Kid Vicious, Sarja Campbell, or Militant Agnostic. So with that, if I do make another video on Bill Gaede, it will be about 7 hours long because why not? I do have to make a 7-hour long video at some point, and this seems like the perfect opportunity. If that's something that you're interested in, make sure to subscribe and ring the bell notification icon so that you get notified of when I post that video. But anyway, I will see you in the next video. Between you and me, yibbidi-dee, that's all, folks!
Okay, okay.